Hello students and welcome back to Standard 9th Mathematics Digital class. Today we will learn remainder theorem. Now students, there is a relation between the value of p of x for x is equal to negative a, that is p of negative a. We have learned how to find out the value of a polynomial in the previous video, and the remainder when p of x is divided by x plus a. So let's see what is the remainder theorem. Let p of x be any polynomial of degree greater than equal to 1 and let a be any real number. If p of x is divided by the linear polynomial x plus a, then the remainder is p of negative a. Now let's understand this with an example. So here we have taken an example. Divide p of x equals to 4x square minus x plus 2 by x plus 1. So we will divide this polynomial by x plus 1. So let's divide it. 4x square minus x plus 2. Here we are dividing it by x plus 1. Now this method we have already seen. So now let's divide it. So x multiplied by dash will give us 4x square. So we have to multiply with 4x. So here we have to take 4x. Now this 4x will be multiplied with both x and plus 1. So let's multiply. 4x multiplied by x is 4x square. Then 4x multiplied by plus 1 is plus 4x. We have to subtract here. So we will change the sign. So this sign will change to negative sign and this positive sign will change to negative sign. So your positive 4x square and negative 4x square will be cancelled. Now we have negative x and negative 4x, which is equal to negative 5x plus 2. Now again x multiplied by dash equals to negative 5x. So we have to multiply with negative 5. So we'll write here negative 5. Now this negative 5 will be multiplied with both x and positive 1. So let's multiply. Negative 5 multiplied by x is negative 5x. Negative 5 multiplied by plus 1 is negative 5. So again we have to subtract here. So negative sign will change to positive sign. Here also negative sign will change to positive sign. Now negative 5x and positive 5x will be cancelled. Okay. Now we have positive 2 and positive 5. So this will give us 7. So therefore our quotient is 4x minus 5 and our remainder is 7. So let's write it. Quotient equals to 4x minus 5 and remainder equals to 7. Now let this be equation number 1. Now we will find out the value of polynomial p of x. So here we have p of x equals to 4x square minus x plus 2. So we have the divisor as x plus 1. So we will take x plus 1 equals to 0 to find out the value of x. So x is equal to negative 1. Now we will substitute x is equal to negative 1 in p of x, so that we can find the value of polynomial for x is equal to negative 1. So let's substitute. P of negative 1 equals to, here we have 4x squared. So 4 multiplied by negative 1 square minus, then again x will be replaced by negative 1, then plus 2. So this is equal to 4 multiplied by negative 1 square is positive 1. So let's write it. Minus multiply by minus is plus. So plus 1 and then plus 2. So this is equal to 4 multiplied by 1 is 4 plus 1 plus 2 is 7. Thus, P of negative 1 is equal to 7. That is the value of polynomial for x equals to negative 1 is 7. So we can write here the value of P of x for x equals to negative 1 is 7. Now let this be equation number 2. Now see equation number 1 and equation number 2. Here we got the remainder as 7 and here we got the value of P of x for x equals to negative 1 as 7. So these two are equal, right? Thus we can say if a polynomial P of x is divided by a linear expression x plus a, then the remainder will be same as P of negative a. That is the value of polynomial for x equals to negative a. Now let's see an example. So here the example is, by using remainder theorem, divide the polynomial x cube minus 2x squared minus 4x minus 1 by x minus 1 and find the remainder. So here polynomial is P of x equals to x cube minus 2x squared minus 4x minus 1. Now the divisor is equal to x minus 1. So therefore take x is equal to 1. That is, you can take x minus 1 equals to 0 so that the value of x will be 1. Okay, so we have to take x is equal to 1 here. Therefore, remainder is equal to P of 1 equals to. So we have to replace x by 1. So 1 cubed minus 2 multiplied by 1 squared minus 4 multiplied by 1 minus 1 by remainder theorem. So this is equal to 1 cubed is 1 minus 2 multiplied by 1 squared is 1 squared minus 4 multiplied by 1 is 4 minus 1. So this is equal to 1 minus 2 multiplied by 1 is 2 minus 4 minus 1. So this is equal to negative 6. So therefore remainder equals to negative 6. Okay. Let's see one more example. If the polynomial t cube minus 3t square plus kt plus 50 is divided by t minus 3, the remainder is 62. Then find the value of k. Solution. Here, when the given polynomial is divided by t minus 3. Okay, so the given polynomial is divided by t minus 3. The remainder is 62. So what is the meaning of this? It means that the value of the polynomial when t equals to 3 is 62. So we can write this as P of 3 equals to 62. This is given. Okay. So now let's start with the solution. The polynomial here is p of t equals to t cube minus 3t square plus kt plus 50. So we have to substitute t equals to 3. So we can write here, substitute t equals to 3 in the above polynomial. Okay, so we will replace t by 3. So p of 3 equals to 3 cubed minus 3 into 3 squared plus k into 3 plus 50. Okay, so now let's solve it. 3 cubed is 27 minus 3 multiplied by 3 square. 3 squared is 9. So 3 into 9 is 27 plus k into 3 is k3. K into 3 is 3k plus 50. Okay. Now 27 minus 27 is 0. So we are having only 3k plus 50. So 3k plus 50. Now p of 3 is already given as 62. So we'll substitute p of 3 as 62. So let's substitute here. So now we have a linear equation in one variable, that is k. Okay, so we'll solve it. So 3k plus 50 equals to 62 we have. So 3k equals to 62 minus 50, which is equal to 12. So 3k equals to 12, or k equals to 12 upon 3. So 3 ones are 3 fours are. So therefore the value of k is 4. Hence we got the value of k. I hope students you have understood remainder theorem. Thank you.